Hey guys, welcome to mathspays.com. We're looking at trigonometry, finding angles using SOHCAHTOA. So this is a follow-on lesson from finding sides. Briefly, hopefully you remember and you've seen the last lesson that we looked at the introduction of SOHCAHTOA. Okay, where SO was sine theta equals the ratio or the fraction of opposite over the hypotenuse. Cos theta was equaling to the adjacent over the hypotenuse, and then finishing off with tan theta equal the opposite side over the adjacent side. If you know two of those three pieces of information, so for example that last time we had an angle and a side, we'll then be able to find the missing side. But in this case, what we're going to be looking at, we're going to be given the sides and we're being asked to find what the angle is going to be. Slightly different. There is a little bit more technicality in using the calculator and a few more calculations, but generally speaking, it's pretty straightforward. So we're going to look at an example to start us off. I'm just going to draw this down. You might want to draw this down as well. I'm going to draw a nice little right angled triangle, because remember, we are looking at, and I'm just going to put on here, right angle triangles. Okay, so in terms of our right angled triangles, let's have a look. I'm going to put this as theta. We'll say this is 10 centimeters, and we'll do this as 12 centimeters for the hypotenuse. So in this case, we're going to be asked to find theta. Of course, there is different roundings, which I'll speak about in further questions. In this case, we're just going to do it to the nearest degree, which is the nearest whole number. Okay, because remember, when you're finding angles, angles is in degrees, minutes, and seconds. So, like we saw last lesson, the very first step is still the same. That means we want to label the sides. Okay, so in regards to theta, the 12 centimeters would be called the hypotenuse because it's opposite the right angle, and the 10 centimeters would be the adjacent side because it's next to the theta. So we've got the adjacent side. Okay, so I'm going to write that down. So hypotenuse and adjacent, which means that for H and A, okay, or A and H, we're looking at cos. Okay, so the second step would be to write our rule with our information in. Now in this case, we don't know what the angle is, so we've got cos theta. We do know the adjacent is 10, and we do know that the hypotenuse is 12. Okay, the good thing is you're never going to have a letter on the bottom here, okay, because your letter basically is the theta. But this is an issue, right? Because we want to find not what cos theta is, we want to find out what theta is. Now, I guess in your mind, you might think like algebra, you know, what's in between the cos and the theta, and you might think, oh, well, it's kind of like they're next to each other, so it's going to be cos times theta. So what's the opposite of times cos? It's going to be divided by cos. Okay, so you might throw 10 over 12 into your calculator and say that's going to be, you know, 0.83 or whatever it's going to be. But this divide by cos is a really big issue, right? The problem with divide by cos is that if you put in your calculator divide by cos, cos is always associated with an angle. Therefore, because you're not putting an angle in, you press equals, you get a math error. All right, it doesn't quite work. So you may or may not remember in our index laws that if you divide by cos, that's basically what divide by cos means, right? That is actually the same as doing cos to -1. It's a negative index. Okay, you might remember that. If you've done that, that's great, and if you remember it. If you haven't, don't worry too much. But the main thing is we can't divide by cos. So instead of dividing by cos, we use the button on our calculator, cos the -1, and then type in the 10 over 12 in our fraction. Okay, now if you look on your calculator right now and you look above the cos key, often in a different color, most likely yellow, you'll see a little cos -1. So what that actually means is that to get the cos -1 button, you're actually doing shift cos. Okay, and we always need to do that when we're finding an angle, whether it's sine, cos, or tan, we want to get rid of the cos, sine, or tan, and we can't divide, so we use the shift cos, shift sine, or shift tan. So I'm going to press it now. So shift cos, it comes up with cos -1. I type in my fraction of 10 over 12, and then I press equals, and then we come up with 33.557 ... which we set to the nearest whole number, which is 34 degrees. And so we've got our angle of 34 degrees, and that's pretty much it for sine, cos, and tan. You just need to remember to press the shift cos, shift sine, shift tan. That's really, really important. If you don't, then you won't get the correct answer. In fact, your answer is usually going to be less than 1, so it's going to be like a very minor angle. Okay, look, I want you to have a crack at this next question. We're going to do it to the nearest degree just like we did. First of all, find what rule you're using, and I want you to go through the process and see how you go. Okay, welcome back, guys. How'd you get on? So from this rule, the first step, we're looking at labeling the sides. This time, this is the opposite side because opposite theta. This is still my hypotenuse. Now, I was naughty. I didn't put in my right angle. I should have done that. But we've got that there. That's our hypotenuse. So opposite and hypotenuse is going to be our sine. So sine theta, because I don't know what the angle is going to be, equals my opposite over my hypotenuse. Now, I like you to write this step in, please, to start off with. Later on, you might be able to skip it, but certainly to help you remember that whenever we're finding theta, okay, we need to press shift sine, shift cos, or shift tan. So in this case, we're doing shift sine, okay, which gives me sine -1. Type in 5 over 6 in our calculator, press equals, and we get 56.44 ... ellipsis. That just means it goes on. I'm now going to round my answer to the nearest whole number, 56 degrees. I'm going to put a little square box around it so I can see that's my answer. It's not a bad idea, guys, when you're showing you're working. I mean, theoretically, you're going to get 1 mark from there and 1 mark from there. This stuff, though, will certainly help you with your marks. I think it's important to keep that in there. Okay, next question now. I want you to give this a crack. You might want to start by doing this to the nearest whole number, okay, the nearest degree. If you have an idea about how to do the nearest minute, then you can certainly do it, but I'll go through that with you. But have a quick crack now, and we'll get back to it. All right, so how'd you go? Okay, so theta, we've got our opposite side here, and we've got our adjacent side here, which means we're using tan. So tan theta equals my opposite over my adjacent. Now remember, we can't divide by tan, so I'm going to use tan -1 and type in 8 over 5 onto the calculator. Okay, I'm going to enter that in now. So shift tan, chuck in the 8 over 5, and then press equals. Now I'm going to write 57.9946 ellipsis. Okay, that just makes sure that it continues. Now obviously what's the nearest degree, so the nearest whole number, you would have 58 degrees, but this time it says the nearest minute. Hopefully you will remember on your calculator you have this little degrees, minutes and seconds button. Okay, it often looks like this. I often refer to it as the bubble button because it kind of looks like there's a whole pile of bubbles. On some calculators though, it might say DMS. They're the older calculators, which means degrees, minutes and seconds. And what we can do, we can press that button now and it will come up with this whole thing of 57 degree sign, 59 minute sign, and then 40.62 seconds. Now if we're doing to the nearest minute, okay, so I said it's degrees, minutes, and seconds. That means that I'm rounding the 59, and like your decimal rounding, the next one tells me what happens. Now, usually we know it's like 5 and above it goes up, but we're talking about time. Okay, degrees, minutes, seconds. Degrees goes up to 60. It's kind of like hours, I guess, etc. So seconds, there are 60 seconds in 1 minute, which means 30 seconds is the magical number. Now this is 40.62 seconds, which means that this is going to round up to being a final answer of 57 degrees And actually, it goes up to 60 minutes, doesn't it? So in fact, it goes up to 58 degrees and 0 minutes. Haven't seen a whole lot of questions that happens to. Funny enough, that one happened there. But we'll do a bit more of that kind of stuff later on. I'm more interested in you being able to find the actual angle, and most of the questions at the moment, guys, will be to the nearest degree anyway. Okay, next question. Have a pause. This time I'm asking you to find two different angles, theta and alpha. You can find either one first, and then you've got a few different ways to find the other one. So have a quick go and let me know, or press play and we'll figure out how you went. Okay, so I'm going to find theta first, guys, because that's kind of what we've been doing, right? In regards to the theta, we've got the adjacent side and we've got the hypotenuse side, which means adjacent hypotenuse, we've got cos. If you found the alpha, then what you've actually got is the opposite and the hypotenuse side. Okay, which would mean you're using sine. So same situation, okay, but just slightly the adjacent side will swap over to the being an opposite side. But in this case, we've got cos. So cos theta equals my adjacent, which is 12, over my hypotenuse, which is 15. To find my theta, we're doing cos the -1, okay, and doing 12 over 15. And then we're simply typing that into the calculator, shift cos. We're doing 12 over the 15 and then letting our calculator do the work. Now, I've said to the nearest degree here, so my answer is 36.869 ... which means we've got 37 degrees. Just for your interest, guys, if you did it to the nearest minute, okay, it would have been 36 degrees and 52 minutes because it's below 30 seconds. But we don't want that, we want the nearest degree. Now, the good thing is you've got two separate ways of doing the next question. Okay, as mentioned, we could say using alpha as this is my opposite side and this is my hypotenuse side, and we could say that's going to be sine alpha is equaling to 12 over 15, and then doing shift sine 12 over 15. And that what you'll find there, if I do shift sine and 12 over 15, we're going to come up with, to the nearest degree, 53 degrees. But I wonder if you've got another way of doing that. Okay, have a think about this. What is the angle sum of a triangle? Well, the angle sum, so add those three angles together, it's 180 degrees, but in fact we know that's 90. So realistically, these two angles will add up to 90 degrees no matter what happens. All right, that can also be called what we refer to as complementary. Okay, complementary add to 90 degrees, which means if that's 37, 90 minus 37 equals 53 degrees, and look, that's what we had. So in fact, all I needed to do was to find one angle and do angle sum of a triangle or complementary angles, and we could go from there. Okay, look guys, that's finding angles of trigonometry. As I said, a little bit different from the sides, but basically the same. I'm going to do a follow-up lesson now with just a bit of a trig review, so feel free to have a quick crack at that video as well. Otherwise, as I said before, drop me an email. Have yourselves a good day.